Hi, and thank you for joining us today. Today we're going to talk about the FreeWave ZumLink Radio. We're going to cover its basic features, the methods for configuration, and also the ZumIQ application environment. Today's topics that we're going to cover are the feature and specifications overview, the different hardware components, how to configure it, the benefits of using ZumIQ application environment, how to connect through USB, how to connect through Ethernet, and then also the critical settings that you'll need to know in order to have radios link up to one another. Here's an overview of the ZumLink Ethernet radio. So this is a project that's been 24 years in the making. This continues on the success of the 900 megahertz FreeWave radios that are well known and well loved. It is a unlicensed radio, specifically in the 902 to 928 band. There are multiple data rates available. So this is a big advantage over using FreeWave's traditional Ethernet radios. There's a lot more granularity in adjusting the speed versus distance there. So in traditional FreeWave Ethernet products, there are only two RF data rates, and in ZumLink, there are many RF data rates to give you that adjustability between speed and distance. Another difference between FreeWave's traditional radios and ZumLink is the ability to operate in a single channel mode. So at the higher data rates, at 500K and above, you can now operate in a single channel. The output power is 1 watt, which is the maximum allowable limit by the FCC for the 902 to 928 space. It is a native Ethernet radio, and it also has serial capability. So if you have an Ethernet device or a serial device out in the field, this radio has connections for both those types. The range on the radio is up to 60 miles with a clear line of sight. Well, I'll say that 60 miles can be achieved in the most ideal conditions. More realistically, in field environments, you'll probably see approximately 5 to 15 miles of range. The air-free communication, so if you put any message into a radio, whether it be ABC, the message that will come out on the other side will be ABC. We have a way to check for that, and if something comes out the other side, like BCA, it'll toss that data out and ask for it again. The diagnostic capability on the radio, so we have a way to look at network diagnostics and check the signal levels for all radios that are deployed in the field. The noise immunity. The ZumLink radio will operate well in congested environments. Even though it is an unlicensed device, there are several different features that help ZumLink work even in the most congested environments. And last is the high reliability. So FreeWave makes rugged industrial products that are tried and true in environments all over the world. We have radios that operate in North Dakota in -30, -40, and we have radios that operate in Saudi Arabia in the summer when it may be 130, 140 degrees out. So we have that entire temperature range taken into account for there, and every radio is tested in our manufacturing facility to meet that temperature specification. Let's take a look at some of the other features on the radio. So again, one of the biggest advantages in moving to ZumLink over FreeWave's traditional products are the throughput that ZumLink offers. So the actual TCP throughput is around a meg and a half, whereas on the HT Plus, the product that ZumLink is replacing, the TCP throughput was roughly 300 to 500 kilobits per second with that. So essentially you're 2 to 3 times as fast as the HT Plus radio with ZumLink. Some of the other features we offer here is it's more than a radio. It can host third-party applications. It's more than a radio. It's an industrial computing platform at the edge, and that allows you to do a lot more with data than just send and receive it over a radio link. We have point-to-multipoint and peer-to-peer capability. So any network topology can be achieved with ZumLink, and we have a lot of flexibility in that. Security is becoming a hot topic in the industrial sector, and all of our wireless communications are encrypted using 256-bit AES. For those customers that want to move from other FreeWave products to ZumLink, we have a coexistence plan for FGR and HT networks, and that app note is available for download from our website. The transmission choice is here, so as I noted earlier, it can operate in a single channel mode or also a frequency hopping mode, and both types of transmissions have their own advantages and disadvantages, and we leave that up to the user to decide what the best is for their network and their application. The power consumption, so in industrial spaces, sometimes power sources may not be reliable. There may be battery backup, or it may be running on solar. So ZumLink was designed with those low power applications in mind. And you can take a look at those power requirements on the spec sheet and also noted below here. New to the ZumLink platform is something we call Adaptive Spectrum Learning, or ASL, and that allows ZumLink to operate it in those congested environments that we spoke of. Using ASL, the radio will listen before it transmits, so it's making sure there's a break in the airspace where it can get its message through, and it will learn the best times for the radio to transmit there. Forward error correction, or FEC, improves the reliability of data transport in congested, noisy RF environments. By using a little bit of throughput, we can add a little bit more data to be able to correct those packets if they're corrupted over the air. We also feature packet compression, and packet compression will try to remove unnecessary information from our Ethernet transmissions, so we can only put the data that's important and not any extraneous data that may go with the packet. Next is the packet aggregation. So if you have an application that uses a large number of smaller packets, we can combine those into one packet to make the radio link more efficient, and then we can send that out in a single packet. The last feature here on the page is IP filtering, and this is a very important feature for Ethernet products, and this is something that's new to the ZumLink platform. This did not exist in other FreeWave Ethernet products. IP filtering allows us to block specific radio traffic at the gateway itself. So you can block out extraneous broadcast traffic. Maybe there's some other types of Ethernet traffic that are not destined for the radio network, and we don't want those messages being sent over the radio link and using our time and throughput on the network. Using the IP filtering scheme, we can make sure that none of that data is sent out over the airwaves. Let's take a look at the hardware for ZumLink. Here's the front of a radio, and the LEDs are very similar to what you are used to on other FreeWave products. The green CD light will indicate that the radio has a link. Other ports available are, we have two serial ports that can do 232, 485, or 422. There's a single Ethernet port, there's a micro USB port, and also a TNC antenna connection. Of special note here is the micro USB port. So in past FreeWave Ethernet products, you either had to go through a serial port or an Ethernet port, and if you went through the serial port and you didn't have a serial port on your laptop, you had to use a USB to serial converter. Now with ZumLink you can use a micro USB port, which charges a lot of Android phones that are on the market currently. So that'll allow you to access the radio without having to use a USB to serial cable or without having to change your IP address. So having a micro USB port on a radio product is a big advantage. There are three ways to configure a ZumLink radio. The first is via the USB port, and you can use a micro USB cable to do a drag and drop configuration, or you can use a command line interface known as CLI. The second method is SSH, which is a secure Ethernet protocol. So that requires an Ethernet cable, and also you have to change your IP address, and you have to know the IP address of the radio. The third way is using the Web GUI interface. So this also requires an Ethernet connection to the radio, and that will allow you to log into a web interface that's embedded on the radio and make changes through a graphical web-based environment. The first method we're going to cover is USB configuration via the CLI. And the difference between the USB CLI and the SSH is SSH requires an IP address and an Ethernet cable. If you want to configure via CLI and just use the micro USB cable, this is the method you will follow. After you've plugged into the radio via your micro USB cable, you then need to open up a terminal emulator program. In our example here, we're using a terminal emulator called PuTTY, and you need to connect to the COM port that the radio is connected to. If you're unsure of what COM port you're using, you can use the device manager in Windows to see a listing of the COM ports and which one you are connected to. Once you connect, you'll see a login prompt, and the login and the password are both admin. Once you see the FreeWave shell text, the CLI interface is now ready to accept commands. To see a listing of all the menus via the CLI, type pages and then press enter. To see the menu associated with any of the listed pages, you can simply type in the name of the page and it'll show you all the results for that. In the example here, we've typed radio settings, and all the radio settings are currently displayed. If you need help in understanding what a setting accomplishes, you can type help, space, and then the name of the setting. The next configuration method we're going to talk about is the web interface, and this is very similar to other FreeWave Ethernet products. To enter the web interface, you need to know the IP address of the radio in question. If you're unsure of what the IP address is, you can always plug in via the micro USB cable and go to the drive that shows up for ZumLink, open the file, and then you'll see a group of text files. And the config.txt file, if you double click on that, it'll bring up a text file of their current configuration. In there you will find the IP address listed. Once you know the IP address of a radio, you can then change your computer's IP address to be within the same subnet. Once you're connected with an Ethernet cable, you can then type in the IP address of the radio in a web browser and then go to /config after the IP address. That will bring you to the login screen, and again, the username and password are both admin by default, and this will give you everything that you could see in the CLI pages, now with a graphical interface. The most commonly adjusted settings on a ZumLink radio are the data rate, the hopping mode, and the radio mode. The first setting there, the data rate, determines the possible throughput the network can achieve and also what distances you're going to be able to cover. So with wireless technology, there's always a trade-off between speed and distance, and the different RF data rates available on ZumLink help you select the most optimal setting for the link, distance, and signal path that you're looking to achieve. If you are using an RF data rate of under 500 kilobits per second, you have to use the hopping mode per FCC regulations. If you are using an RF data rate of 500 kilobits or greater, you can use the single channel mode. The RF data rate must match on all of the radios in the network. When you have a frequency hopping network, there must be a gateway for that network. One of the radios must be configured as a gateway radio, and this gateway will help synchronize all the other radios so they're following the same hopping pattern. When a ZumLink network is set up to be not frequency hopping, or also known as single channel, the gateway is not required. And the over-the-air data rates available for non-hopping, as I mentioned, are 500K, 1 meg, and 4 meg. This allows all the radios within the same vicinity or RF range to talk to each other directly. And in a single channel network, a gateway is not required. If you would like to set up a repeater, please see the ZumLink user manual at the URL listed below. The ZumLink common settings that must match on all radios in a network are the radio hopping mode, so hopping is either on or off, the network ID, which determines what radios can talk to each other, the RF data rate, which specifies the speed of the network, and then also if you have FEC or forward error correction on or off. For more information on the FEC rate setting, please see the ZumLink user manual. In contrast to the common settings, there are also settings on a ZumLink radio that must be unique for each radio in the network. And the first one is the node ID. And the node ID helps the network organize itself and understand each other's position in the network by a numerical system. If you're in a hopping mode network where there is an established gateway, that gateway will always default to a node ID of 1. So all node IDs must be unique in the network, and the gateway will always be set at 1. A good system to use in order to keep all your node IDs separate and unique is that you just use the last 3 digits of the IP address for the node ID. In speaking about IP addresses, ZumLink being an Ethernet device also must have a unique IP address. Troubleshooting and support. After you've configured your network, you may log into each web interface and look at the local diagnostics page on a radio. And the most commonly looked at variables here are going to be the signal level and the signal margin. Here we have a signal level of -41, which is extremely strong, and we would expect that link to perform well. For more details on what signal levels you need to achieve at each RF data rate, please see the spec sheet or the ZumLink manual. For each RF data rate, there is a sensitivity level, and the sensitivity level determines how good your signal level must be in order to achieve optimal performance for that RF data rate. In addition to local diagnostics on an individual web interface for a radio, you can also use a command called show channel diags. And show channel diags is executed through the CLI that we previously discussed, and this command allows you to see a listing of all other radios in the network that the radio can hear that you're currently logged into. It will show you the node ID, and that's why it's important to have unique node IDs. It'll show you the signal level associated with that node ID. If you're having trouble with your ZumLink network, there is a support bundle that assists free-wave technical support specialists in troubleshooting your network and providing you with a resolution. To access this support bundle that's required by free-wave personnel, you go to the IP address of the radio /support, and it'll create a zipped file of all the information that we would normally ask a customer for when we're assisting in troubleshooting a network. Introduction to ZumIQ. ZumIQ is an application environment that runs on a ZumLink radio. The ZumLink radio is based on a Linux operating system. That allows ZumLink to host applications that could normally run on any other Linux-based system given the hardware constraints of the ZumLink platform. Preloaded on each ZumLink developer model are applications like Node-RED, Mosquito, OpenPLC, and some other useful development tools. So ZumIQ is a platform, not a specific application. ZumIQ allows you to develop your own applications, or you could build applications outside of ZumLink and then install them and run them on ZumLink. And ZumIQ is enabled with specific firmware and also a license available from Freewave. Think of ZumIQ as an industrial Raspberry Pi per se. So this allows hobbyist developers and other technical professionals to develop code and applications that can run on a radio. So it's no longer just a radio that simply sends and receives data. You can also develop applications that run on ZumLink within the ZumIQ environment that can interact with that data. For example, you could write an application that checks the signal level of all the radios and then writes it to a database. If you're interfacing with a Modbus system, you could also write an application that pulls in Modbus data, stores it for 6 months on the ZumLink radio, and then also displays it in a web-based dashboard. Other ideas for ZumIQ are collecting, displaying, and analyzing any type of data that may pass through the radio. A common way to prototype applications is to use Node-RED, and Node-RED is a graphical programming environment that runs on top of JavaScript, and that allows you to graphically create a flow-based program using a set of what are called nodes, which are simply blocks of different code to achieve different common functions in programming. The hardware available on ZumLink for development has 1 gig of flash storage and 512 meg of RAM. This is more than enough processing and storage power for many applications that would be run in industrial environments. Freewave also has other applications planned for development, and these applications that will run in ZumIQ will give you better diagnostics, better insight into your network and how it's performing, and other tools that will assist in the management of that network. Here's an example of ZumIQ in action. Here we have ZumIQ being used to pull in data that shows the water level of a storage tank. It then sends that data some distance, maybe a couple hundred feet, maybe a couple miles on site to where there's an Ethernet backhaul with wide area connectivity, and that data is then pushed to the cloud for hosting. So the code that actually runs this is hosted on the radio itself, and it allows ZumLink to pull in that Modbus data from the IOE 4422, send it back to where there actually is a connection to the internet, and then that data is then published to the cloud and can be viewed from anywhere in the world. If you need help with ZumLink and the ZumIQ development platform, you can call us toll free on 866-923-6168, or you can email us at moreinfo@freewave.com. Our developer resources on GitHub, so github.com/freewave technologies.